Today we're going to be talking about writing equations. So the last unit we did writing expressions. So this is just kind of a continuation on it. You should be looking at those same keywords. So the reason that we kind of put addition and subtraction in the same box and kind of remove this line in between is that when we're solving equations, we use those inverse operations. So our initial instinct is to go straight into solving, but we need to practice writing them algebraically. So the problem might have addition in it, but you're going to solve by subtracting. Or the problem might have subtraction in it, but you're going to solve by addition. We only are doing multiplication because we are only going to focus on equations that have multiplication in the problems. So let's look at the steps to solving equations. Steps to writing equations. So these steps should be very similar to what we did for writing expressions. The first thing we're going to do, we underline the unknown variable. We're asking ourselves, what are we solving for, and then defining that variable. Usually, you're going to see this in the question part of it. Okay. Step 2 is we're going to identify key information. So we are going to circle all numerical values given to you in the problem. Exactly what we did for writing expressions. Part 3, we're going to highlight the words that determine the operation. So we're going to highlight those words that tell us the operation using that chart above. Then we're going to determine what the total or end result is. We're going to set our equation equal to this value. And then what's important to note is that your equation must be algebraic, okay? Our instinct is just go straight to solving. We need to practice setting up an equation. So the variable should never be alone on one side of the equation. So this one is an algebraic equation. The variable has an operation and a number with it. So that's algebraic. This is not algebraic. The variable's on its own. There's no operation. There's no number. Okay? So let's look at number 1. 3 more than a number is 12. So first thing I'm going to do, I think that's easiest to actually start with, is to circle the numerical values. So I see 3 and 12 is given to us. Then I'm going to go through, I'm going to use my chart. I'm going to highlight the word that means the operation. Okay. So looking at this, the word that tells us the operation here, if I look on here, more than tells us addition. So I'm going to highlight more than. I'm going to write a little plus above that because that tells me we're using addition in this problem. Now I'm going to define my variable. What is the unknown? We're going to underline that. So in this case, we don't know what the number is, so I'm going to say n equals a number. So now let's set up our equation. I like to start when I'm setting up with the total. It's easiest to set it equal to the total amount. So is 3 our total or is 12 our total? In this case, it's 12. A key word that tells you equal is the word is. Is telling me, okay, this part is equal to that value of 12. Okay? Generally speaking, with the problems that we are going to be working with, the bigger number is going to be what it's equal to. It's not always the case just for this one. So now we go back. We have 3 more than a number. Whenever I see more than, it goes after. So I'm adding 3 to something. What am I adding 3 to? I'm adding it to that unknown number. So we're going to worry about solving later. Right now we're just setting up. Number 2, the product of 7 and a number is 28. So again, I'm going to go through, I'm going to circle my numbers that are given to me first. 7 and 28. Next thing, I'm going to highlight the key information, the key words that tells us those operations. So if I look product, I see that means multiplication. So I'm going to highlight product, and I'm going to write X above it because that's multiplication. And then what's our unknown? Similar to the last one, we don't know what the number is. I'm going to say n equals a number. Now let's set up our equation. Starting with what it's equal to. Is our total 7 or is it 28? The total is 28. It's equal to 28. Now we know we're multiplying 7 and that unknown number. The best way to show that you're doing 7 times the number is just to write them right next to each other. 7, n. All right, let's flip it over to the back. Number 3, 7 less than a number is 20. So first thing, I'm going to circle my numbers, 7 and 20. Next thing, I'm going to highlight the words that mean the operation. If I look on this chart here, less than tells me subtraction. So I'm going to highlight the words less than. I'm going to write a little minus sign because I know that I'm subtracting. So my unknown in this case, again, I'm going to underline, is a number. So n equals a number. Now, which one's our total? Is 7 or 20 our total? It is 20. It's equal to 20. We know that our operation is less than. Remember, these are these tricky ones. Does less than go before or after? Whenever we have less than, more than, younger than, older than, we know it goes after. So 7 less than means I'm subtracting 7 from something. What am I subtracting it from? A number. All right, number 4, PETA uses 7.5 cups of flour to make 3 loaves of bread, of banana bread for Katniss. How many cups does it take to make 1 loaf of bread? So first thing, again, still easy. I'm going to circle my numbers, 3 and 7.5. Next thing, I'm going to look for my word that tells me the operation. It's a little bit difficult here. If I'm looking at this chart, I don't see any addition or subtraction words, but these multiplication words, some of them can be trickier. Of, per, for, every, each, one, how much for one item. When I look at this, it says how many cups does it take to make 1 loaf of bread? So as soon as I see that 1, I know that this is a multiplication problem. And then our unknown, the last 3 have just been a number, but this is an actual word problem. So I often look at the question at the end of the problem. So how many cups does it take to make 1 loaf of bread? How many cups? We don't know the cups. I'm going to say C for cups equals the number of cups. So now let's set up our equation. Is our total for the recipe 7.5 cups or 3? It should be a total of 7.5. We know it's a multiplication problem, so we have 3 times our variable of C. When we show multiplication, we're just going to write them right next to each other. 3C. All right, number 5. Lisa is cooking muffins. The recipe calls for 7 cups of sugar. She already put in 2 cups. How many more cups does she need? So let's circle our numbers. We have 7. We have 2. What word tells us the operation? I see the word more, which tells me addition. So I'm going to highlight the word more. I'm going to put a plus sign. And then again, we've got a word problem here. What is the unknown? I'm going to look for the question. How many more cups does she need? So again, we're looking for the number of cups. Let's set up our equation. Is our total 7 or is it 2? The recipe needs 7. That is our total amount. Then we know we're adding. How many more cups does she need? So she's already used 2 plus how many more cups is she going to need to get the total? Since it is addition, is it okay to flip that around? Yeah. All right, number 6. The total time it takes Dan to mow 1 lawn is 15 minutes. Last weekend, Dan spent 165 minutes mowing lawns. How many lawns did Dan mow last week? So I'm going to circle my numbers, 15 and 165. I'm going to highlight the word that means the operation. So again, I don't see any of these words here. I start looking at the multiplication words. I see the word 1 again. It says it took him this time to mow 1 lawn. So that tells us it is a multiplication problem. And then our unknown, I'm going to look for the question, how many lawns did Dan mow last week? So our unknown is how many lawns. L kind of looks like a 1, so I'm just going to use a generic X for X equals number of lawns. Let's set up our equation. The total amount, is it 15 or 165? The total that he spent is equal to 165. Now we know it's multiplication. 15 times our unknown amount of lawns, we just write that as 15x. So we did somewhere we were just writing the equations. Now let's look when we write and then we solve. So number 7, how many lollipops can you buy for the Valentine's Day sale if you have $26 and each lollipop costs $2? So first thing, let's circle our numbers, 26 and 2. Highlighting the word that tells us the operation. I don't see anything about more or less, but I do see the word each, and each is a clue word for multiplication. So I know this is going to be a multiplication problem. And then our unknown. So usually our question's at the end. This time it's right from the beginning. How many lollipops? That's what we don't know. Again, L kind of looks like a 1, so I'm just going to say X equals number of lollipops. So our equation is 2 the total, or is 26 the total amount that you have? 26 is our total. So then 2 times our unknown number of lollipops, we just write as 2x. Now we're actually going to go through our solving process. So I'm going to draw my line down the equal sign. I'm highlighting my variable, so I'm looking at the side that the variable is on. We already know that multiplication's in the problem, so we have to divide. The number that we're going to divide by is the one that's with the variable. So we're dividing both sides by 2. 2 divided by 2 cancels out. We're left with just x equals 26 divided by 2 is 13. Since it's a word problem, we should include units. What were we solving for? Our variable should represent the number of lollipops, so 13 lollipops. All right, and then number 8, and then we're going to go on to the you try. So last week, Julia ran 30 miles less than Emily. If Julia ran 47 miles, how many miles did Emily run? So I'm going to circle my numbers. We have 30 and we have 47. I'm going to highlight the word that tells us the operation. Less than tells us subtraction. And then what's our unknown? I'm looking for the question. It says how many miles, and specifically did Emily run? So I'm going to write M equals miles Emily ran. For our equation, is our total amount 30 or 47? If you're stuck, remember I said most of our problems, the bigger number is going to be what it's equal to. We saw less than, so 30 less than should tell us right away it comes after. We're subtracting 30 from something. What are we subtracting it from? The miles. Now we've got our equation to solve. Draw our line down the equal sign. Highlight our variable. So the side the variable's on, we have subtraction. We need to solve by doing the opposite, which is to add that value of 30 to both sides. On the side with the variable, it should cancel out. We get M equals 47 plus 30 is 77. We were solving for miles, so I'm going to write 77 miles.